Okay, ladies and gentlemen, here we are. The Monday before Thanksgiving break. T minus four, if you count today, it'd be 5 days, but we are almost there. This is Mr. Din once again, broadcasting from Los Angeles. How's everybody doing? Hopefully you guys are doing okay. This lesson is a continuation from last lesson about animal phyla. And so I would like to show you the agenda for today. Looks something like this. Okay, so lesson 6, Brain Jog 4 is on animal phyla, just animal. This goes on page 26. I'm going to post a video that I'd like you to, I'm going to post a video about 2 organisms that I'd like you to add to your Pokédex. So one is called a lichen and the other is called a grouse. These are 2 very distinct organisms and they're pretty cool. Number 3, we're going to finish up our animal phyla explanation on page 31. And then I'm going to introduce to you the first lesson of the second part of this unit. So everything from this point before has been about biodiversity. How do we classify organisms? But then from Darwin forward is going to be about looking into the past. Where did these organisms actually come from? And how do these organisms change over time? And so the second part is going to be about something called evolution. And the introduction to Darwin is your first glimpse of what evolution is about. That's our agenda. Stop that share. And I'm going to show you where looks something like this. We are not on page 29, we're on page 31. We're going to finish up our animal phyla today. Okay, and at the very end of the video, I'm going to talk to you about this beak activity that we usually do in class, and it's pretty fun. The beak activity gives you an idea about how evolution works. Okay. With that introduction, let's talk about animal phyla once more. I believe we left off talking about Annelida. Now the annelids, I'm sure everybody is quite familiar with. These are worms. You also have these segmented leeches that are also annelids. So let's get going, shall we? So the annelids are very interesting. The reason I've drawn these little lines on them is because these annelids are segmented. So E stands for external features. They are segmented, so they have different regions of their body that are lined so that each section is particularly distinct. They have both a mouth and anus separately, so they eat in a different hole than they poo. And these organisms are all bilateral. I know a worm doesn't seem bilateral. You can actually perform a dissection of a worm and cut down the midline, kind of like you can cut down the midline for a human being. And their skeleton is quite interesting. So it's not a rigid skeleton like that we have in our bodies. Instead, they have a fluid skeleton. They're both our bodies and their bodies have internal skeletons, but theirs is fluid and ours is rigid. It's pretty interesting. The arthropods are also interesting organisms as well. Here's a crab. think one year I drew Mr. Krabs. There we are. And you can't forget about the centipedes. Have you guys ever seen a centipede and a millipede? These creatures are quite, what's the word I'm looking for? Intimidating, I guess, would be the best word to describe them. Centipedes, crabs, lobster, etc. Scorpions are arthropods as well. They have a mouth and anus. These are separate holes, mouth and anus. Now, what's interesting about arthropods is that they are also segmented. So this part is the arm and this part is the body, and centipedes also have lines to them like this. They are segmented. And they have a hard exoskeleton. Exo meaning outside. So our skeleton is an endoskeleton. It's on the inside, but theirs is an exoskeleton. These organisms are also bilateral. And like I said earlier, they have an external skeleton. You guys are probably familiar with this if you've ever eaten crab before with that little crab hammer. You've also experienced this when you crush, say, like a centipede, and you hear that crunch. That crunch is you breaking the external skeleton, the exoskeleton. That's arthropods. And finally, chordata. And that leads directly to you and me, chordata. It's called chordata because they have a spinal cord. Spinal cord is spelled without the H, but you guys get the point. I've drawn an owl before, and of course, you and me. They have a separate mouth and anus. I know some of you guys, it's a little hard to tell. I messed that joke up. Man, usually I can get it down pat. What else do we have? We have internal fertilization. That means that when a sperm meets an egg, it happens on the inside of the body. And we give birth externally. You know what, maybe I'll put up a video of a horse giving birth. It's kind of hard to see a human giving birth, but horses giving birth can be quite interesting. We have bilateral symmetry, and also we have an internal skeleton. Now, branching from phylum Chordata are 5 groups of organisms, let's put it that way, that we also learned about in our stump speeches. Birds, fish, reptiles, amphibians, and mammals. Okay, let me give you a summary, then I'll give you the context once again. Summary. There are a variety of different animal phyla that we can investigate, from Porifera to Cnidaria, Platyhelminthes. Mollusca, Annelida, Arthropoda, and Chordata. All of these phyla underneath have many different families, many classes, many orders, many genuses, and obviously many species. It would be incredibly foolish of the human species to think that we are above other organisms, that we are above nature. We're not. We happen to be the dominant species right now, but for the majority of Earth's life, we were not. And so we have this human arrogance to us that we think, oh, we are beyond nature, and so we must control nature to assert our dominance. And that's not necessarily true. Human beings can live in harmony, in balance with nature. And so when you look at this, I don't look at it as a set of facts. I don't say, Platyhelminthes as this, and that's a fact, and this is a fact, and this is a fact. No, I look at it as a family. We are all a part of this biosphere. And so for me, that's the real core of this lesson. It's not the facts. It's looking at shared life. Okay. With that said, I want to once again transition into the second half of our unit. These organisms I introduced to you, do they stay the same throughout time? Do they change throughout time? If they do stay the same, then why don't they change depending on the environment around them? If they change, what is the trigger for that change? So change over time of a species is called evolution. What we're going to investigate from here on out is how evolution works. And I'm going to introduce to you a man who didn't think he would become very famous. His name is Charles Darwin. So I'm going to stop this share, and I'm going to show you the activity that we're going to do about Darwin's finches. So when I first heard of a finch back in high school, I'm like, what the heck is a finch? It sounds like a nickname or a fish or something. And it's a bird. A finch is a bird. And so what you guys are going to do is you're going to read the background information. You do not have to complete the activity. You don't have to do the data processing. What I would like you to do is I'd like you to think about the activity and try to answer these analysis and conclusion questions. So you start off with a bunch of finches on an island. Over time, what happens to the finches? Do they all stay the same? Does the species change, etc.? I don't want you to use the internet for this assignment. Don't do that. It says distinguish the difference between evolution, natural selection, adaptations, and mutations. Don't do that. Try to think about it. Put it in your own words. Obviously, we haven't gone over it yet, so there's not a lot to for you to get wrong. So just give it a shot. And with that, I'm going to stop that share. I'm going to say that hopefully you guys are preparing for your practicum on Thursday. And that's it. That's all I got to say. Miss you guys. Bye.